Hi students, today we are going to continue with the chapter sets and we are going to solve some sums where we are going to convert the data in the roster form to the data in the set builder form. If you remember in the last video we had spoken that roster is just a listing of the data, right? It's just a listing of the data, or it is also called the tabular data. I mean, you can see on the left-hand side how this is just a listing of that information, while the set builder is a representation through a rule, and hence it is also called a rule method. What we do is the entire data can be represented in just one line, in just one single statement, building an argument, right? Building an argument in one line. How do we do that? I had just given you a small example last time. Today I'm going to talk about some rules. The moment you follow those rules, you cannot make mistake. There are some basic 2-3 rules. What are those rules? First, make a curly bracket. The set builder starts with a curly bracket. Okay? The data will lie between the two curly brackets, and this is going to be uniform across. Whatever may be the question, this cannot change. Next thing which is going to be uniform across this would be the variable x such that, the variable x such that, right? This I'm going to continue in the entire series of these questions. Now it becomes interesting. Now it's very, very important to understand what are two ways of representing data. Can you see this series 2, 4, 6, 8, 10, 12, dot, 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 which means this series continue. These are even numbers and they continue up to infinity. Now, if this data continues up to infinity, I can write that this is following a pattern x is equal to 2n, where n is the element of natural number. Now this set builder has got two parts. X is such that one is the equation which satisfy these numbers, these pattern. And second, I'm also telling that this n is a part of the natural numbers. N is a natural number. Now this n can be 1, 2, 3, 500, 2000, 10,000 till the infinity, right? This is how we write the set builder. But what if this dots would not have been there? This would have been a limited data up to 12. Then in that case, I will add that n lies between 1 and what? 6. Because the moment I put n is equal to 1, I get 2. The moment I put 2, I get 4, 3, 6. And when I put the last number 6, I get the last number, which is 12. Now, I'm just trying to explain that this is very simple. All what you have to remember is the curly bracket starting with x colon, x is such that an equation will satisfy this series, and then you have to either give this range or you don't have to give this range. You give this range when there are limited numbers. You don't give this range when it is an open-ended series which never stops. Let's move to the second one. What I see is that these numbers are multiple of 3, right? So I can say that x is equal to 3n, right? Now, n is the element of, can you guess what? Should I write natural numbers or should I write whole numbers? Why whole number? Because this series starts from 0 and 0 is a whole number. So I cannot write natural number because natural number starts from 1. The moment I put 1, I get 3, which is the second. So I miss out on 0. So this has to be, the first number has to be 0. The moment I put 0, I get 0. Now this is a fixed series up to 18. So I will have to give a range for n. What is that range? That this n lies between 0 and what? 6. Because the moment I put 6 here, I get 18, which is the last number. Follow these rules and you cannot make mistake. Third one. Now, this is again a very similar series. What I'm missing is 3 and 0, right? So how am I going to write? X is equal to 3n plus 3. And since this is an open-ended, this range will not come here. Remember that. What will come? N is the element of natural number. Because the moment I put 1, I'll have to start with 1. I get 3 into 1, 3 plus 3, 6, and that is my first number. Right? So this is what you have to understand. That one, you have to write an equation which satisfies the series. And second, you have to figure out whether it's an open-ended numbers or it is a closed-ended with a range. Let's move to the next one. This is interesting. This will be a bit different, okay? Again, I will not change those basic things. X is such that, what is the condition here? Can you make out? Are these odd numbers between 10 and 20? No, these are not odd numbers between 10 and 20, which means there is something which is unique here. 11, 13, 15 is missing, 17, 19. These are prime numbers. These are prime numbers between 10 and 20. So X is such that X is a prime number. X is a prime number where X is lying between 10 and 20. I hope you understand all these signs. X is lying between 10 and 20. And I'll have to write a single statement. X is a prime number because these are prime numbers. There is no equation. X is a prime number. This is all what I can write. So X is a prime number. X lying between 10 and 20. The moment you see a fixed series, there has to be a range. Let's move to this one, curly bracket. X is such that. Now you have to be quick in understanding what this series is about. So this series is talking that there is a variable because it is moving in the numerator also and in the denominator also, n plus 2. Now, can I write that n is the element of natural number? No, I cannot, because in the numerator, these are all odd numbers, which are natural, but these are all odd natural numbers. So what I'm going to write, Control Z, n is the element of all odd natural numbers. That's it. Close with a curly bracket. That's it. Keep putting commas everywhere, right? Wherever it is required, please keep putting commas. I hope you have understood. This is very important in n plus 2, but I can make out n is equal to 1. N is equal to 1. I get 1 upon 3. 1 plus 2, 1 upon 3. Now the next odd number is 3. So 3 upon 3 plus 2, 3 upon 5. 5 upon 7. This continues. So there is no range here. Let's move to the next one. Again, the curly bracket. Again, X is such that what? X is such that I see the cubes here. X is such that X is equal to n cube, where n lies between, n is the element of what? Natural number, right? N is the element of natural number. But now since there is no open-ended series, I'll have to put a range. What is the range? That n is lying between, it starts from 2 and it ends at 6, because 6 cube is 216. Curly bracket closed. I hope you're understanding, liking few things, few basic rules. There are no dot, dot, dot. So it has to be a range. I have put in the range. N is the element of natural number, because we are only talking about natural numbers, right? Let's move to this one. This is again a bit interesting. Curly bracket that cannot change. X is such that, now these are integers. So X is such that X is the element of, how do we represent integers? Either by Z or by I, either in Z or I, followed by X is the element of Z, right? X is the element of integers. But what I'm seeing is there is no continuation of the series. So my X is lying between minus 5, sorry, and -1, right? And close the curly bracket. Good enough? Perfect. Let's do this last one. Put the curly bracket. Now you see that this is an open-ended series, right? This is an open-ended series. So am I going to put this condition? I'm not going to put this condition, right? One thing for sure is that X is such that X is equal to 3n, because these numbers are a multiple of 3, right? -6, -3, 0, 3, 6. These are all in the series of, this is all a multiple of 3, right? X is equal to 3. Now, n is the element of all integers. N is the element of all integers. This is open-ended series, so can I put a condition? No. N is the element of all integers. Similar to this one, N is the element of all natural numbers, right? It is an open-ended series. This is an open-ended series. Anywhere else there is an open-ended? Yes, this is an open-ended series. So N is the element of odd natural numbers. There is no range. I hope I have been able to make you understand the difference between the roster and the set builder rule, and also how to put the data in this form to the rule method. See you in the next one.